Okay, so thank you for joining. This is a post-flight briefing for the N-2 rocket launch at the Seattle, which has been held on 23rd, Wednesday, 2 days ago. So first thing first, so this is a brief summary of our launch. So we have successfully launched 3 rockets, which is basically those 3 are N-2 rockets. All of them are N-2 family. The first launch, we have launched Tana, which has reaction wheel as attitude control mechanism. For the second launch, we have launched Perkera or Pekera. It has active canal fins to stabilize the roll movement. And for the third launch, we have launched Garana, which has a function of parachute ejection by manual override. So those 3, all of them are N2, but each has different characters. And yeah, we try to test each functions as is expected. Now, so let me show you the video.
1, ignition. Go, baby, go.
So as you see, so what happened? So you can see this one was launched vertically. So the initial movement was okay. However, actually, there is a ejection of the nozzle. So that's why the rocket lost the stability immediately. Then another thing is it didn't eject the parachute. Oh, okay, so it ejected the parachute. However, the parachute didn't spread or expand. So that's why we couldn't successfully recover the rocket using the parachute. Yes, so this is it has a reaction wheel mechanism, but apparently it loses the control. So, but maybe the telemetry team can give us the flight log, the attitude data, so that we can discuss further. So this is Tana. Then the next rocket is, oh, this is the Tana. Next rocket is Pekera. By the way, I was wondering why it's the Washington shooting this one. Yeah, so I just wanted to know the trajectory, but yeah, I hope the KSA team is shooting the video and they will give us later, I hope. So anyway, so actually it reached quite high altitude, then, but as similarly, it didn't eject the parachute or spread the parachute, so it comes off just straight. Okay, and so we wanted to know the apogee because it recorded highest apogee for the 3 rockets. However, there was a kind of accident. Telemetry teams were supposed to direct the Wi-Fi antenna to track the rocket so that we can communicate. However, due to the preparation of the 3rd rocket, which is Garana, they were quite busy and they couldn't do that. Or yeah, it was basically the oversight. The rocket launch for the 2nd one and 3rd one. It was quite hasty because KSA people were kind of pushing us to complete all of the rocket. But anyway, I'm going to suggest it later, but we have known information such as the flight time for 12 seconds. And we may know the weight of the rocket. And I hope we have kind of a partial flight log from the telemetry. And also we have thrust estimated simulated data. So by combining such information, I think we can estimate the achieved apogee. So that's another task for our team. So let me go to next. Oh, this is Pekera, sorry. The third one. So
7, 6, 5,
this is Garana.
4, 3, 2, 1. Ignition.
Yes. So what happened for Garana? Actually, as I mentioned, the purpose of this rocket is to confirm the performance of the manual override. So manual override means for the first rocket and the second rocket, it was automated ejection, meaning when it reaches apogee, it will automatically eject the parachute. However, we wanted to confirm the redundancy function, which is manual override. So basically, this is a command generated at the ground station that triggers the parachute ejection manually on the fly. So, but however, what happened is that for when we were preparing the launch for this Garana, the final rocket, because of the short circuit, the parachute accidentally fired and it was popped off from the body tube. So due to the limited time frame, we couldn't prepare the parachute again. So we decided to launch it without the parachute. So basically, we were unable to confirm the performance of the manual override. So this is one information. And the second information, as you can see,
3, 2, 1. Ignition.
yes, because of the generated thrust, you can see the launch pad is tilted because of the force. Yes. So that's why it was almost launched for the 45 degrees Celsius. And it went quite far from the launch point. So that is Garana.
7, 6.
Yes. So to summarize, so what we have achieved in Isioro. First, and maybe most important, we could work with KSA and we could successfully launch 3 rockets. So even though there are many things we couldn't achieve, but at least 3 rockets which we have prepared were launched. So that's what's good. The next point is a solid rocket motor. And actually it worked pretty nice. And for the first one, as I mentioned, the nozzle was ejected, but the propulsion team found a way, kind of a workaround to solve the issue. So they decided to hammer the edge of the combustion chamber so that they can fasten tightly the nozzle. It can hold much tighter. So due to this change, for the second one and for the third launch, it didn't come off. Even though for the second one, the bulkhead, instead of a nozzle, the bulkhead came off. However, it was actually, it proved the quite good performance. Next one is related to telemetry. So telemetry system worked well. So it could transmit the flight log, gyro data, altitude data, as well as camera from the ESP32 camera, which is quite good. The avionics team detected the ESP32 resetting issue, so that is related to the second launch. Just before the second launch, it took time to solve this issue. So ESP32 didn't generate a signal, but they could identify the issue was caused by the resetting. So they have to reset once, after the external power source is provided. So this procedure they have found. However, when they were pushing the reset switch, accidentally they could, damaged the reset button, so it came off. But they fixed it by analyzing the connection using the other avionics board, so that they could fix it very fast. So it was a kind of achievement. The next one is related to the recovery. So they could fire the crimson powder, and actually they could eject the parachute, even though it didn't expand. But somehow, to some extent, we could prove the performance. Next one is a launch sequence. So basically, it was Samir working on it, and he could identify the list of the sequence, and the team followed it rigorously. So it was good. Pekera achieved a stable flight, so it has active in control. Then it has achieved the maximum apogee among the 3 rockets. Finally, the airframe, it was actually, it is good. Airframe accommodated all the subsystems without failure. So it was light enough. It has sufficient strength. So that is commendable. So this is achievement. And as I mentioned, I want to task you to calculate the apogee or estimate the apogee of Pekera, because we want to know it to publish it, our result. And as I mentioned, the flight time was about 12 seconds. So let's estimate the apogee using the available information, such as the weight of the rocket, thrust curve, which is simulated, and partial flight log data taken from the telemetry system, etc. So this is the N-2 launch simulation from the open rocket. So from the simulation, I have found that they were estimating the maximum apogee is more than 1,000 meters. So, but they didn't. And this is a time frame. So after the launch, as I mentioned, the flight time was 12 seconds, which is here. And this is 0 altitude above the ground. Now, so if our motor is something, our motor had something similar to this simulated motor, it should have this kind of trajectory, because it's basically, it didn't have a parachute, so it looks like a parabolic flight. It's not completely parabolic because the thrust is changing time by time. However, we can estimate the apogee, like 350, 400, 450. So this is our task using mathematics and physics. I think we can do it. So that's the first part of my presentation. So if any members have any comments, like findings and recommendations for the launch, you can let us know. Any members? Feedback?
For telemetry, we have a post-flight report.
Oh, okay. You have a report, like a presentation.
Just a presentation slide, yeah.
Oh, okay. So then let me quickly go through my presentation. Is it okay?
Yeah.
Okay. Thank you. Any other comments?
I have a comment.
Yes, please.
So I was presenting
Caleb, we lost you. I think you have connection issue. We cannot hear you. Yeah, maybe you can check the connection and audio. Once you come back, I give you the chance to share. Meanwhile, does anybody have opinions, feedback? Correct. You can go ahead.
Yeah, so that was the recommendation from the supervisor.
Mm-hmm.
He said that for the for the nichrome wire to take some seconds to heat up,
Mm-hmm.
but for the one where we are using a transformer, which it is kind of an instant. So it might be better than the nichrome wire. So yeah.
So what is better than nichrome wire? Could you say that again?
The transformer, a transformer.
Okay.
I have not ascertained whether it is the current transformer or it is a voltage transformer, but it is that mechanism that is used in a car engine to create the spark, and the spark is instant.
Oh, okay. So is it regarding the crimson powder, right? Or is it for the
Yeah.
ignition? Okay,
Yeah.
crimson. Okay.
Crimson.
Yes. Thank you. Any other comments? Any other comments? If not, let me proceed. Okay, thank you, Caleb. Okay. Now, I want to basically in this meeting, I wanted to talk about the improvement. Definitely, we have to improve ourselves. So we couldn't achieve something, and so we have to continuously work on it. Now, let me share my view. There are two perspectives. The first one is about the management of teamwork, management of development, and so on. So this is a kind of organizational issue. The second item is a technical issue. So let me share or point out in detail. So let me start from the management issue. So basically there are two, like a development timeline should be fixed or improved. And also we have to avoid the last minute work. I think I think this is needless to say, but let me emphasize it again. For the technical issue, I have listed 4 of them. I think there are many others, but I just picked up 4. For example, the first one is recovery system must be seriously prioritized for our development. Next is the entire rocket subsystems have to be redesigned for smooth assembly. So this will help us to assemble our rocket as well as deassemble our rocket. The third one is about the telemetry or avionics board. So it only had kind of, so it didn't have memory inside. So it has an issue. So if the communication is disrupted, there is no way to recover our flight log. So it should be improved. The last one is about the launch pad. So launch pad was taken care by the team of propulsion. However, I want to suggest something so that we can improve our launch pad. So let me go through it. The first one is about the development timeline. So there are 2 timelines, like the actual timeline we have followed and the ideal timeline we must achieve. So starting from the actual timeline. Actually, we have been working on the N-2 development since actually January. So we started the internship 2022 January and it ended in May. But after May, this plan, the launch of B0 has come from KSA. So we just rebooted ourselves to prepare for the launch. And however, I understand you are quite busy, but basically we have to change our mind because for the next launch, we have to adapt ourselves. What I want to say, this is launch day, 23rd. This is T-1 day, which is 22nd, 1 week before, 2 weeks before, 1 month before. Now, we had achieved a final static test for the solid rocket motor 1 week before, just 1 week before the launch. And actually, I understand it was difficult to complete it, but we could have done much earlier. I can say that. And just the day before, all of us remember that we have been working at IPIC until 8 or 8:30, very late. And we casted, we have created avionics bay, assembled avionics bay, and even on the last day, we have been printing something, like a 3D printing. And the recovery team were working on the PCB soldering, and active pin control team are also doing that. But it shouldn't happen next time, because this is just the day before. So ideally, everything must be completed a week before. And actually, I said that. It is okay, or it is understandable, but for the next time, I suggest we are going to conduct an integrated test by assembling everything. And we are going to rehearse the launch by using the actual launch sequence. Like it's a kind of a dry run, so we don't fire it, but we do the same, like T-5, 4, 3, 2, 1 ignition, like we test. So such a rehearsal is a must. Because I said there was a missing item in the list of the sequence, which is directing the antenna to the rocket. So if it is covered in the rehearsal, I think this would have been avoided. So I strongly request we do for the next time, we are going to do it much earlier. I understand the casting of the motor cannot do, because when it, it will be deteriorating as time goes by. But we can cast it, I think 2 days before, so that we can mount the motor a day before. Yes. So on the launch day, we have been working. Even at the site, we are working, but it should be avoided. So ideally, what we do, we arrive on site, we set up, launch, and go home. Just that. So no extra work should be done on site, like a soldering, like assembly. No. So this is, I think we should improve next time. And if it can be done, I think we should, I think Isiolo was very far, but if we can follow such a very smooth procedure, I think it's still feasible to do the next launch at Isiolo. Yes, but otherwise it's very challenging. So this is words by Linus Torvalds. As you may know, this is inventor of Linux. So he is saying that we should avoid such a last-minute work like a high school students. Okay. Now let me elaborate it again. So we should avoid the last-minute work. So as I mentioned, this is a Wi-Fi antenna to communicate with rocket. Yes. So so by avoiding the last-minute work, we can avoid the oversight. So for example, yeah, this one. It could be avoided if we prepare the launch procedure from a rehearsal before the launch day. So that's my observation. And we were assembling the avionics bay 1 day before, or even on site, but should be done way before the launch. So insertion of avionics bay must be done way before the launch. And to insert the avionics bay into the airframe, we should have avionics bay, of course, as well as the airframe. So it meaning, actually we were printing the avionics bay a day before or 2 days before, but it shouldn't happen next time. We should prepare all the avionics bay maybe 1 month ago, then airframe 1 month ago, so that we can assemble with a lot of margin of time. So that's another suggestion. And actually, we didn't do the integration test. And I think we are just lucky we could launch it. However, we should do the integration test of a launch rail, launch rug, and airframe. I observed there was a kind of a dust or rust on the launch rail, it may hinder the smooth ejection of the rocket. So we have to confirm everything is all right before the launch. Okay, and actually it was another accident, like for the Pekera. One of four, it has 4 canal pins, but out of 4, 1 fin was damaged before the launch due to the bad location of the launch rack. So actually, my opinion, the launch rack has to be set up before going to the launch site, meaning at the laboratory, we have to set up the launch rack. Number 2, the location or positioning of a launch rack must be done in the design. So actually, after fabricating airframe, we could make, we are making ad hoc holes, like we were making holes, kind of improvising the holes so that we can accommodate the cable, we can accommodate the reset switch, we can accommodate the battery, everything. However, it should be avoided. It should be fabricated as designed on the 3D CAD, meaning the 3D CAD rocket airframe design must have the holes. Okay, so in fact, we didn't prepare the precise 3D model for the airframe, but for the next model, we have to do it. And we have to actualize the 3D design as it is. So that's my suggestion. All right, so this is the kind of organizational issues. Then let me move on to the technical issues. The first one is a recovery system. So I suggest that the recovery system must be seriously prioritized. The reason. So as I said, that was unfortunate. None of the rockets succeeded the recovery. It ejected, but the parachute didn't expand. For the moment, we cannot convince our partners like KSA or maybe the civil aviation that our launch is safe. But if our recovery is very reliable, we would be able to test our rocket at much nearer place. I think we don't have to go to Isiolo if we can convince our partners. Okay, but if we not, like for example, if there is a possibility of ejecting a rocket onto 45 degrees Celsius, it will go for. So it is dangerous. So we need to go to secure place like Isiolo. But it is not kind of sustainable. So I think we have to prioritize this recovery system. Okay, so for the next internship in 2023, starting from January, I suggest the avionics team will concentrate on the recovery as the first priority, because we have developed the telemetry system, developed avionics system, and most of the functions has been done. However, recovery is yet to be achieved, so we have to prioritize. Next one is about the airframe and all the subsystems. Let me show you the video. So this one is 22nd November, 1 day before the launch. So we were trying to push the avionics bay onto the airframe. As you can see, it's very hard to insert. However, this happened due to the tolerance. So meaning the precision is not enough. I mean, not high enough. So there are something like first one is we should fabricate our airframe with much higher precision. Okay. Also, there are many ways to do this. The first suggestion is to use aluminum mold instead of a PVC mold, so that we can have much precise airframe using a fiberglass. I suggest we are going to use, we can also use another material such as aluminum tube or CFRP. So this will be another challenge or task for the intern students for airframe. And as I mentioned, so this is what I have mentioned in the previous slide. We should avoid making ad hoc calls at the last minute. Like, okay, it doesn't come in, so let's put holes here. Or, oh, it doesn't, fit, so let's make a hole here. No, it shouldn't happen. Design everything on 3D CAD, then comply with the design. Yes, so this is improvement. Okay. And the third one is the internal memory addition to store the logging data. So if our flight control board or avionics board had internal SD memory or SD card or any flash memory, we would have been able to capture very good video. So that was a bit unfortunate. So let's work on it. That's my suggestion. So finally, about the launch part. So launch part was quite okay, but I think we can still improve it. The first one is about the fixture or the how to fix the launch part. Okay, so actually there are 2 wires to tighten it. However, by the rotational moment, it rotated. So we have to improve it. And actually, not only the fix of this launch part, but also we have, I think there are still room for improvement in terms of smooth ejection, like launch rail and like a launch lag and so on. So yes, we can also focus on this one in the next internship. All right, so let me mention the way forward to finalize my presentation. So first one is about the timeline, and the second one is about the internship. So after, oh, okay. So why it's moving? Yes. I'm considering the timeline of Nakuja project. So this is N2 launch, and this is one of the milestones. However, which direction are we going after the N2? I have to clarify it so that the team has a common understanding and move as a consistent team. So now I am redefining the solid milestones to achieve our final goal, which is the development of the wicked rocket. Okay. So as all of us understand, there are 2 streams, like the solid rocket development and the wicked engine development. So both of them continues, but I'm going to clarify the milestones, like by when we should do what. Okay. And with that being said, let me mention the internship from January to May 2023. I listed 4 teams. I don't want to expand our topic too much. So considering the N2 launch, I want to propose that we have to concentrate on only 4 topics listed here. First one is about avionics. As I mentioned, we have to achieve the reliable recovery system. Team 2 is related to the airframe. So we are going to modify our rocket body as well as launch pad. Now I restructured so that the launch pad is involved in the airframe team. Now team 3 and team 4 is propulsion. Both of them are propulsion, but the team 3 is the solid propulsion, which is the development of a composite propellant. Team 4 is also propulsion, but it is working on the wicked rocket engine test stand. Actually, it is initiated by the mechatronics final year student, and they are going to take over their jobs from January. I proposed the first batch and the second batch as we did in the 2022. So it will start from January 16 in the middle of January, then it will continue up to March 24 for 10 weeks. And 5 students will be allocated into each team. Now, as we did for this year, this year, the first batch student can enter or can join the second batch. So they can continue. They have a right to continue. But if they don't want to continue, it's okay. And for second batch, they are going to start slightly before the end of first batch so that they can take over the tasks. So they will join from March 13th, and it will end in May 5th. So there are slight difference, like first batch is 10 weeks, and the second batch is 8 weeks. Actually, the first batch is the kind of a prioritized students, like existing Nakuja members, the members who were suggested by Nakuja members who were suggested by the faculty members, like Dr. Mushiri, Oiti, Dr. Patrick, Mr. Manegene. So, so this is a kind of primary interns. Then this is secondary interns. Okay, so this is my proposal for now. This is not a fix, just a proposal. Let me quickly go through. So the reliable recovery system. There are main objectives and the sub-objectives. Main objective is something they must to achieve. Sub-objective is they can achieve as they have time. Okay. The must is the mechanical rejection. I'm saying mechanical rejection instead of pyrotechnic. So we have been working on the pyrotechnics for 3 years and never succeeded. I think we have to drastically change our mind. So I suggest that we are going to start the mechanical rejection system. So that is my proposal. For the second one, the parachute expansion, simulation, and implementation. Yes, the parachute ejected, but it didn't expand. So I think we have to study the parachute. Everyone thinks a parachute is easy, but it's not. So we have to, we need a holistic study about the parachute. Okay. I say that mechanical ejection is superior to the pyrotechnic, but it may not, because parachute ejection was achieved for the N-2 launch, but issue was the expansion. So if we can confirm the parachute expansion, this objective, maybe we can also consider, we can still consider the pyrotechnic as an ejection method. So let me keep it open. The real-time tracking using GPS, that's what we didn't have this time. So let's do it. Onboard data logging, as I said, it should be implemented. And basically, we are going to take over the N2 avionics set. So I don't want the new students to start from scratch. They have to study the existing asset, then they are going to customize what we have already built. Okay. Sub-objectives are something like a long-range data transmission, so they can think about it, but this is not a must for now. So we have to prioritize our important tasks. Okay. Dual deployment, yes, it might be considered, but this is kind of secondary objectives. Airframe, the main objectives, there are 4. So they will consider the alternative materials such as aluminum or CFRP. GFRP is still considerable because Mr. Evans from the glass fiber expert, they have suggested another method using aluminum tube, using a resin, epoxy resin, and using another type of glass fiber mat. We may improve the precision. So in this case, GFRP is still to be considered. However, they will study the aluminum and the CFRP and find the best method. Next one is about the total redesign of substructures, like parachute, nose cone, avionics bay, solid motor. Basically, the redesign means we have to coordinate all the subcomponents. Otherwise, we will have the same issue, like we have to push the avionics bay onto the airframe. That shouldn't happen again. So it should be easily assembled or disassembled. Also, we have to think about the way, like we have mounted the camera at the last minute. So we have just used the vinyl tape, but it is agreed. So we have to design how to mount the camera, how to mount the reset switch, how to sort out the cables, how to put the GPS antenna, everything on the 3D CAD level, meaning the design level. at the design stage, we have to sort out these issues instead of working at the last minute. The next one is about the identification of the rocket parameters, like a center of gravity, center of pressure, moment of inertia of area, and the mass. So because we were working just before the launch, we couldn't have time to identify such a rocket parameters. But if we work earlier, we could identify all the rocket parameters, which is instrumental for the simulation. So next time we will do it again. We will work on this. Last one is the stable launch path and the improved launch lag for better deployment. It worked this time for the N-2 launch, but still, I think we can improve our launch path system and launch lag. Sub-objectives is identification of drag coefficient and the aerodynamic coefficient using a wind tunnel or CFD or DATCOM simulation. But this is kind of a secondary objective compared to this. Next, the propulsion, the composite propellant. This is very simple. We are going to achieve the rocket motor, which has a specific impulse ISP greater than 200 seconds. The theoretical performance of KNSP, our current propellant is 120, 130. But actually, if we achieve the APCP, ammonium perchlorate composite propellant, for example, we can achieve a double of our current motor, which is significant. So as we aim to much higher apogee, I think we have to work on this composite propellant as the other university or other rocketry, high power rocketeers are working. The second one is about the improvement of our static test stand. So I want to make it efficient. So what I'm talking about is when we are going to test static test, usually it takes 1 hour or maybe 2 hours because we have to prepare for the static test. But I think we can make it more efficient. Yes, by maybe basically we have to think about it and implement it. The subject objectives are listed here, but it is just nice to have. So our objective is just a composite propellant. Fourth one is a liquid rocket engine test stand. Now, 50 students, 6 students are working on the liquid rocket engine. They are quite progressing. However, they may not achieve what they designed initially. So they are going to, the interns are going to take over to accomplish the water test for low pressure and full pressure. So this is kind of mission. I want to put the firing test in this one. I'm eager to do it. However, safety is most important. So at least we have to test our test stand using a full pressure water testing. Then everything, if everything is okay, we can proceed with the firing, which is more dangerous. So basically, that is my presentation. I think you can put comments, but maybe before doing that, let me invite Ian to proceed with his presentation. Thank you.
Good evening.
Good evening.
I'll try to be brief. So let me share my screen. So basically, these are telemetry and avionics flight reports for the flights and of N-2. So overview, we have a preparation, assembly, launch, results, post-flight analysis, challenges, and recommendations. For preparations, over the course of the year, we purchased equipment, testing of all components. We did drone test for state machine and verified that it was working. We also did a couple of range tests for antenna data and video transmission. And then we also did PCB testings. For assembly, we can see the assembly of the various components. You have the Galana avionic system, the Tana avionic system, and the Pakera avionic system. For results, this is the video dashboard video for Tana. So basically, it's supposed to, So this is the data that we got for the Tana. You can see like we had video and data. We have acceleration, velocity, gyroscope values. They were saved to the database. Then, sorry, for Pakera, even though we were not able to record the flights, we got some data, just a small part of the data. Yeah, so the rocket stopped once it got to state 1. We stopped getting data once it got to state 1. Then, for Galana, we only got the video. The ESP32 camera video was good. You can see like people moving without any lags. But then after the rockets, the launch pad inverted, we lost data. It seems like the vibrations are too much, and maybe the ESP camera video, like the power may be disconnected, but you're not sure. Then, sorry. So for post-flight analysis, based on this is for Turner, the data that we got complete. You can see filtered, sorry. You can see filtered displacement against raw displacement. So the raw data that's from the sensors, then we have the Kalman filtered altitude. Maximum apogee for the raw was 122, but you can see it's displayed maximum apogee way before hopefully the actual one. Then we have the filtered one at 99.962 meters. So this post-flight analysis where we have displacement, the filtered displacement, filtered velocity, and filtered acceleration values. We have maximum apogee of 99, maximum velocity of 25 meters per second, and maximum acceleration of around 5 meters per second squared. Then some of our achievements for the flight, we have data transmission, video streaming. We saved data to InfluxDB that was transmitted during communication. We're also able to detect apogee through the state machine. We were able to detect all the various states for the flight that we recorded. We were able to have power supply in the remote location in Isiolo through the inverter and the batteries, and they were able to supply us power for the whole duration of our stay there, which was nice. Then we got real-time display of data and video on the dashboard, as you've seen on the videos previously. We got high data transmission rates. Based on the data that was in InfluxDB, we were able to calculate and we realized that we got 1 data point every 25 milliseconds, which is based on the flight time of 8 seconds, is around 300 data points for around 8 seconds. Then we have PCB design and acquiring from the PCBs from GLC PCB, even though we acquired them a little bit late, which hindered us testing them. We were able to actually get the PCBs and not use the etched ones, which was a nice improvement. Then we got avionics bay design and fabrication. Though also it was late, but at least they were able to fit in the airframe properly. So some of the challenges we had the PCBs were resetting every time they were being supplied by external power supply, which posed a hindrance, especially in installation of inside the airframe. We had to create holes where we'll be able to reset the PCBs. We have avionics bay installation due to the tight fit of the airframes. We were having issues installing the avionics bay as expressed by Dr. Oki, so this resulted in cutting of some of the wires due to the tight fit. We also have an issue with video transmission. You can see that the ESP32 camera is affected by vibrations of the rockets. We might have to look at an alternative into that. We have manual antenna positioning, which resulted in lack of data in the Pakera rocket. It might have been an oversight, but it's also a challenge. Then you have delays in assembly, as highlighted also by Dr. Oki. Then you have GPS locking to satellites. We had an issue with that, but for the second flight, the Pakera one, we actually got GPS coordinates for the first few data points that we got. but it was an issue getting GPS coordinates because the GPSs were taking quite some time to lock to satellites. You might have to look at an improvement like getting better GPSs instead of Neo 6, or just finding a different alternative. Then we experienced an SD card failure to mount issue on the last few days of assembly. Previously, the SD card used to work, but it used to pose challenges where the SD card mounting was a problem. Now, the last few days, we actually experienced a problem where the SD card failed to mount completely. Still trying to diagnose what the main issue was, but this posed a heavy challenge, especially for the flights that do not have communication like the Pakera one. We would have been able to save on an SD card. We'll create recommendations on how to go about improvements on that. So our recommendations are for onboard systems. We have PCB improvements where we create better power distribution boards, how to how to remove the PCB from resetting itself, improvement on the MOSFET. We also had a challenge of the MOSFET going to a high and actually creating a high voltage when the PCB is reset. That's why we had to add an additional switch for ejection. Then you have the storage problem where the SD card failed. We might have to, when you are coming up with the next PCB, we might create an improvement and use externally EEPROMs for storage. Then you have use of a better GPS. Then for onboard also, you need to look into the camera. Like I had stated earlier, we have an issue with the ESP camera with the vibrations, then a better avionics bay design and assembly. Then for ground station, for our system, we realized in the gist of every flight, people were rushing towards the base station requesting apogee, and it takes time to query the database for apogee calculation. So for the next ground station, you'll have to have an automatic real-time apogee calculation that displays the maximum apogee that the flight has achieved on the dashboard. So that is just real-time viewing. Then you also had an issue with the IP addressing of devices, which resulted in no video for the Pakera one. We'll have to do something about that. Currently, we have some devices having static IPs, but we'll try and have a way of also having the ESP32, like the cameras and the Node MCUs having static IPs also. Then, like Dr. Oki had suggested, we're also looking into offline maps for real-time tracking of the rockets. Currently, you can only get the GPS coordinates and input them on Google Maps and look for the rockets, but you're also looking into the offline maps. So thank you, that was telemetry.
Yeah, thank you very much, Ian, for the holistic report. So I'd like to open the floor for the audience for the Q&A. Any questions for myself, Ian, and the other members who have joined? Rodney, please go ahead.
Hello, everyone. Sorry, I was not able to join early. I was requesting first if you could, Dr. Oki, if you could share your presentations. Then on the second part on the telemetry system, I was thinking instead of saving it to the EEPROM, where you had suggested that we save it instead of saving it to SD card, we can use the little FS, which we can be able to get a hold of the internal flash system that is used on the ESP module. I also on the this will necessitate us to store our data efficiently. I think we can borrow the approach from flight control. They are using protocol buffers to store their messages. So it is actually, I think it's binary or it's somehow encoded. So it's not raw strings, which can help us save if we run out of space on the flash memory. Yes.
Okay, thank you very much for your suggestion. I think that's in order. You have suggested many different alternative methods to improve. Ian, do you have any response?
No, it's well noted. We'll look into it. It's a nice suggestion.
Yeah, thank you.
Yeah.
Thank you very much. And for the slide, I have shared the link, so you can access it. And also, I'm going to make a PDF and share. Let me just do it right now. Meanwhile, you can ask any questions, members.
I think in general with avionics, there's need for redundancy of data recording. Like when we went for the launch at the only way to get data was over Wi-Fi. So I think we could have like redundant systems. It just doesn't have to be only the SD card. We could use SPIFs, the SD card itself, over Wi-Fi, even the other, because you have multiple like computers on board, we can record the same kind of data, even though we have different sensors. For example, like flight control, we're able to get our data on the SD card. Like Rodney said, we were storing over protocol buffers. Still, the SD card has some issues because it takes some time to write, but we still are able to capture a large amount of data. So, yeah, just need to make sure there is redundancy. So, for example, in the next slides, we could have all of the computers on board trying to record the same kind of data over different systems, and even like with parachute ejection, to not just rely on a single system or a single code base. Like we could have different ways of deploying as redundant systems on different onboard computers. So if one fails, we can have another system taking over. Yeah, that's it.
Okay, thank you very much. Submit. Yes, the redundancy is another challenge for the avionics team, even for the recovery. Thank you. Michael, go ahead.
Okay. So one of the things I noted from the data that Ian has just presented is that I think the Kalman filter we're using, if you check the highest data point on the raw values, there is still sort of a lag between the raw values and the filtered values, which we actually use to make the decisions. So I think we need not necessarily an overhaul, or we build from what we have, because I feel like the delay could also cause, also seems like if I think we're getting the filtered values much later than they really are. So which means that we try or we attempt deployment of the parachute later. So I think that also needs sorting as part of us working on recovery. Yeah.
Okay, thank you very much for your comment. Yeah, this is well noted. And any response?
Yeah, can I add on that?
Yes.
So, like if you were to implement an advanced Kalman filter, for example, the extended, I think there is need to plan for the entire rocket just beforehand. And this is an area I think we've been lacking. Like the specifications for the rockets are not clearly defined. That's why you have the assembly like the one we had, because it's on the day that we just placed the motors or the electronic stay or the parachute. It's variable. I think it needs to be fixed before, and we have like clear dimensions. And this is also an issue that the team working on Activator had, because like if you don't have clear dimensions that's beforehand, like with the weight distribution, and you're trying to develop an advanced um, control system, not just PID, like it's difficult to implement. Uh, yeah, just because of the variability. So I would suggest that we have like prior to like a new rocket, we get a small team just to get all the specifications set to the letter, and then the different teams can go to actualize and they try to build to the exact specifications. So yeah, like for example, like even with the assembly, like if we were to have like a single exoskeleton, endoskeleton, having all the assembly done on it, and then we just outfit it on the outside with the airframe or multiple section airframe, which would have been easier to assemble. So like, those two options, like it requires planning beforehand. Yeah.
Okay, yeah, thank you very much, Sami, for your addition. Yes, the determination of the specification must be done or fixed much earlier in the design phase. I completely agree. Felix, go ahead.
Good evening. I hope you can hear me.
Yes.
Okay, so my recommendations will specifically go to, first, I'd like to reiterate what Sam's point is. I feel like for the next rocket, the design phase should be so meticulous that we know the exact thrust we need for a motor. How so? Let me just speak of propulsion. So far, with the strides we've made as propulsion with the motor we have built, I feel like our biggest failing, not that we have not failed, but our biggest shortcoming has always been our lack of consistency. And this lack of consistency is brought about by, again, inconsistent processes and the fact that we still don't have we've not yet marked down how to get like the weight of the propellant just right to develop a single motor. So one of the things I think we should do, this is I feel like for one, you mentioned one of the themes is to go to composite propellant. I feel like just before we go to composite propellant, we should set one of the milestones is to harness completely KNSB, because I feel like we haven't yet completely done it. Because if we were able to consistently have like 3 static tests with KNSB with given a specific amount of propellant, and we get this amount of results, it would be like a good stepping stone before we go to composite, because it would be dangerous to go to composite if we are not able to like completely maximize on the amount of fuel we're using. So I think on the side of propulsion, that is one major consideration we're supposed to make. Yeah, thank you.
Yeah, thank you very much, Felix, for your advice. I think this is well noted. I think, yeah, we should think about to improve the inconsistent process during the design phase, and also about the propulsion development. Yes, before going to APCP or whatever composite propellant, we are going to seek the way to maximize or optimize our KNSB. Thank you. Michael?
Okay, so mine, one. So what my suggestion is regarding the planning. Like I feel like we don't all of us, like the sub teams, we get lost in like development at the low level, where every team is somehow working on itself, like avionics or airframe, like where we have like avionics just working to deliver their own whatever, their own part, which I feel also hinders our progress very much. So I feel like we need to have a proper management tool, or even I don't know whether a management team, if that could work, but a proper management tool. Like I remember there's a time we were trying to use GitHub, but then somehow we got lost in it. We don't track issues or something like that. So my suggestion is we need to settle on one proper management tool that we follow, even as the teams, each team follows its own objectives. I feel like even during the internship, I think students or the interns, like you get lost in trying just to present, like each team tries only to present their own progress, but the teams are not intermarried, if I may. So I think this creates a big issue. So I don't know whether you can have a management team or someone completely whose work is completely to track just the how the teams are working. Teams are working individually, but then how the teams are working towards the common goal. And also another suggestion, as we're having new interns, probably in January, if we decide to use GitHub, then we should have a short GitHub training or whichever management tool you're using. You can have a short period of training to ensure that everyone can actually do it and follow this to have like a common goal, all of us. Yes.
All right. Yeah. Very, very, very good suggestion. I think, yes, we've tried many things. We started from Slack, but somehow my impression is, the response speed against the Slack is very slow. So I suggest we will stick to GitHub as we did in the previous internship. And you are right. I think we have to have a kind of a short training for expose ourselves to GitHub. And the one thing I have noticed in the previous internship is I have created a kind of a template to report the progress, and everybody followed this format. It was good. However, there was a shortcoming. I was allowed to use own presentation format or PowerPoint. So basically, they were following the format which I have created. However, there is no consistency or continuity. What I'm talking about is maybe during the week 3, they report something like task A. But maybe the week 4, maybe they can report something the same or similar. Maybe week 5, the same. But we cannot actually, maybe in 1 week, we will easily forget what they have achieved. So they can easily repeat the same presentation and nobody notice it, which is wrong. So I think during the next internship, I don't allow to use each presentation or PowerPoint. We are going to use only the GitHub to report our progress so that we don't lose. Or basically, I want to contain everyone into the GitHub so that the tasks and the progress will be very clear for everyone. Yeah, thank you, Michael, for your suggestion. And Rodney, go ahead.
I just wanted to add on the internship. I had a suggestion since the last time the second batch did most things that the first batch did, for instance, in avionics. So I was requesting if there are some places in attachment where the students can do 4 months. So I was requesting whether if you could ask, let's say, people in the first batch to do up to the second batch, so that they can also guide the people who are entering on the second batch, or it just becomes a 4-month stint of internship. So the 5 + 3, it becomes 8 per team. Then they do the 4 months. On propulsion, I was, let's say, I think from what Michael Kimani has said, we need, let's say, a management team, or I would call it a quality assurance team, because there are some cases, for instance, when I was getting the mass of the motor and the motor casing, there was an approximation rather than the actual value. So these might have affected our simulations, let's say, to favor it or not to favor it. So I was asking if we could, let's say, have, let's say, a quality assurance team where we have, let's say, they check if, let's say, an O-ring is fixed, or if it's not fixed, or let's say, for instance, if the dimensions of the avionics bay is what was specified when they are designing phase. Also, there is a lot of change, let's say, from design phase to fabrication, because I think our initial approximation with the propulsion team, we had an aluminum case. I think the one that was retired, we had that case was fitting well to the rocket based on the first test we did in JQuat. But now when we changed the case, it became smaller and longer. So there was, let's say, a need to redesign to provision either motor mount or to reduce the diameter, which will disfavor the avionics and flight control teams. Also on the fabrication, I think from what you suggested, I've seen the report here suggesting aluminum. I'm not discouraging, but I think my classmates are having issues with not hydromatics, NMC. They're delaying the delivery of, let's say, the product. So outsourcing it might be difficult. And for insourcing the glass fibers, I think I experienced some stigma at the welding workshop. When I used their grinder, they didn't want to touch it because they thought the glass fiber was poison, was cancerous. So I think probably we can invest on, let's say, I think some had a suggestion where we have an oven. It's called what? An autoclave, where we can be able to cure the glass fiber. And for the smoothness, I don't know if the cylindrical grinder at machine shop can be able to help us. So it is, the option we have is sanding it down, because we don't have a cylindric, the lathe machine cannot be able to hold the, I think it was 75 milli, I think it was at 75, and also, yes, the 75 millimeter rocket. So there was an issue. We cannot be able to attain the surface smoothness we required. Yes.
Okay, yeah, thank you for your many suggestions. Maybe let me comment something. For the fiberglass, yes, yes, I heard students were talking about carcinogenic or something about the fiberglass. I did a kind of a quick search, but I didn't find any literature about the fiberglass as this kind of a carcinogenic characteristics. However, I think if we, not cancer, but maybe it may damage the lungs if you don't put their mask. So, but still, yes, I think I have same concerns using a fiberglass. Yes. And for the aluminum, yes, NMC, the complaint, it's understood. Now, there is good news. the CNC rate, it may be better than MMC or maybe as same as NMC. It is coming to JQuat in January. So once we set up, I think we have a really good capability of machining. Yes, so let's hope. I think we are actually we are able to do the in-house publication of such metal things. What else? Rodney was mentioning okay, the QA team, like a quality assurance team. I think it will be a bit challenging for us to set up a new team which is dedicated to QA. However, yes, it's a but I think I suggest we can do kind of a QA exercise or QA meeting. And in this process, everybody must be involved, because I don't want to see the QA will be tasked to specific person and other members are not responsible. So I don't want to avoid. Everyone must be responsible for the entire QA procedure. So everyone must understand what others are doing. So I think in the next development process, we are going to systematically incorporate such a quality assurance process to understand, to confirm the common understanding, so that the development will continuously be consistent. Yeah, some of the comments. Sami, go ahead.
Just wanted to emphasize on a few points. First thing was around collaboration. Yeah, so like there's a tendency for teams to work around their own parts of the rockets. Like it's forgetting that you're flying on a single rocket. So I think like the main pitfall of this is like we stopped having like regular complete team, the entire Nakuja project team meeting, either the weekly or bi-weekly, especially like towards the launch. I think it would have really helped because some issues we didn't really see until like the day before the launch, like the issue Ian had mentioned around avionics and the SD card, because like in flight control, we were relying on avionics to do telemetry for flight control, but we had to implement our own system just the day before. So I think maybe there's a need for those meetings. One thing noted is like last year when we were designing this PCBs that flew, originally we had planned to have 3 of them, that was for telemetry, avionics, and flight control. I think like currently the tasks around avionics and telemetry I think they're trying to do 2 different things, and maybe the load becomes too much for avionics, and some things might not get done. So maybe there's a need to separate this. Yes. And around airframe fabrication, I think we've had like major issues with especially the 56mm rockets because the dimensions are usually not consistent. Like I would suggest like we drastically change the fabrication method. I think like the area around the bubbling up is usually like during the curing process, the outer shell is just exposed to the environment. So I would suggest something like we need to hold it in pressure. It doesn't even need to be in an oven, like maybe just between 2 pipes and held with C clamps or something. Consistent thickness throughout the airframe, and like we can get consistent dimensions. Yeah, so something to consider for the airframe too.
Okay. Yeah, thank you very much. Yes, your suggestion for the collaboration, especially thank you for sharing the challenges when you faced when you were coordinating with avionics and the flight control, and also the airframe, the improvement of airframe. Yes, the necessity is well noted. So yes, we will consider that aspect. Felix, go ahead.
Okay, good evening again. I had one other suggestion. This is for the Nakuja project as a whole, not only for the N-2 development. I was thinking of just like for the interns who are going to come in January, possibly not all of them will have worked on the Nakuja project. And the sadness of the sad fact is that among a majority of the members in the meeting right now, they're 50 years. So they may not be able to continue the capacity in which they were participating in the Nakuja project for the internship period. I was thinking that during the first week of internship or the first 3 days, they could have like an orientation session for every single team. And that is team specific because I feel like from the time that from the first internal attachment to now, we've made like a lot of strides. We've changed a lot of things. And for anyone who's just coming into the Nakuja project, it might look like a lot. And if they are not properly orientated, it seems like we're always going to have to restart the project instead of building it from it. And then the other thing is, if it was possible, they could have now like an Nakuja, like an event, an official event in JQuat where we have like an Nakuja orientation day that actually tells people about what the Nakuja project is. Just like a small introducing like students to rocketry, and then seeing like how many of them will be interested in joining the Nakuja project. Not only just introducing them to rocketry, and then telling them about just the nitty-gritties, and then seeing if one or two or more people would be interested in joining the project. And they would join the project now knowing what it is that would be expected from them. So I think just like when you have like the JQuat Says Tech Week, something like that. So you could have like a two-day event for the Nakuja project, just inviting students to come see what the Nakuja project is about. Since we already now have enough like things to display to actually show what the Nakuja has achieved. Thank you.
Yeah, thank you, Felix. Very, very, very important and interesting suggestion. And I totally agree. Actually, I was also thinking about it, the kind of orientation session by the predecessor, like you. So it's totally in order. So we are going to, for the first week, we are going to invite you as a kind of a lecturer to instruct the incoming students for what should be done and what kind of knowledge is required, and so basically the orientation session must be taken. And also the suggestion for holding such conference or event is really interesting. I think we can expose ourselves to the many students, and also it will, I think it will encourage us to improve our skills as well. So that is noted. Yes. So those two things. Yeah, thank you for your suggestion. Jeff?
Hello, good evening.
Good evening.
So I just wanted to add on to what Michael has said, because most of the challenges that we faced during the launch were as a result of, I'd say, poor collaboration during the development and in the weeks leading up to the launch. So and this one, I'd like to connect it to the 2023 internship, where you also mentioned that one of the challenges that you are facing this year was issues of people reporting the same tasks several times, and being difficult to keep up or knowing which is which at some point, or you lose track of what they've done previously and what they're doing currently right now. I think if we could adopt some form of agile development, which fosters both collaboration, collaboration and accountability. Maybe say using something like sprint planning, although we do use, I think the system that we used last year during our attachment was more or less like sprint planning. I'm not so sure what was used this year, but I think it would hold people accountable, because you define, this is what I have, these my deliverables for this period, and this is what I need to do, this, and then even during such sprint plan meetings, if there are any backlogs, they can be addressed as soon as possible. Yeah, that is just one suggestion that I wanted to make. Then this year, I think the interns were presenting interns, but I don't know if each of the teams had a team leader or they were just working independently. Did they have a team leader? Pardon?
No, they didn't have.
All right. So I think that would be an improvement, because I think a team leader, you cannot always be on the ground all the time, because most of the time the students work alone. So I think having a team leader who you can check up with, maybe at the end of the day, on what's the status of this, how far away this, can keep the members accountable. They don't really have to wait for the weekly meeting. So most of the time, I think people wait for the weekly meetings because that is when they are kept accountable. But if you have a team leader who actually who can follow up on what was promised as a deliverable, would reduce on such issues of people reporting the same thing over and over again and hindering the progress. So I think those are the two recommendations that I wanted to make. And again, I just want to emphasize, because I think one of the tools that really helped us during the first ever Nakuja internship last year was GitHub, and using GitHub, the dashboard for monitoring what's in progress, what's yet to be done, what has been done. I think it's really, really important that we go back there.
Yes, thank you very much. This is well noted. And yes, we are going to have a team leader for each team during the next internship. Yes, I had the same experience. Actually, the Nakuja was better, but for Jibebe, which I started, this year as electrical vehicle development, we also had the interns, but they in the intern meeting, the every week meeting, yes, they reported just we didn't know what to do or something. So yeah, I was really complaining. You don't have to wait for the instruction. You need to act proactively, and you have to ask for advice if you don't know what to do. Don't wait. So, but yes, you are true. You are right. We are going to have a team leader so that they can more organized, and they can we can facilitate their operation. Sami?
Just to add something about interns. I think this year or in the coming year, there is a large number of applications. So I think this presents an opportunity because there's a limited number of slots. So maybe you can make the selection process a bit more competitive, and then you can be able to get like really talented individuals who can really further the development. So I would suggest something like a technical challenge, or like in whatever area they are planning to get into. Like if you get some really knowledgeable individuals, like the starting point is a bit raised, and then you can have like much faster development. Like even with onboarding and things like this, like it's easier if like the person is really passionate about rocketry, and they have like strong technical background. Yeah, I think we can really make headways with that.
Okay, I got it. I really agree. And I am shortlisting the members. One, the existing Nakuja members. Two, members who are students who are recommended by Nakuja members. Three, recommendation from the faculties like Dr. Mushiri and so on. Now, after shortlisting, yes, we can still task the remaining students so that, yes, to confirm their prior knowledge about rocketry so that we can filter more promising students. Yes. Thank you. Samir?
Thank you. First of all, I would like to draw your attention to the chat. There was a question posted by Daniel, and I think you'll be the right person to answer that question when you get the chance to do it. I don't have much of technical recommendations because I think most of the recommendations have been covered by the finalists. We've got such awesome recommendations. Maybe what I can recommend is from the launch, what I experienced. Maybe the launch part, first of all, we can improve the launch part by adding spirit levels and like a protractor or a gauge, because I understand previously I was told that the launch should be at 8 degrees of an angle. I'm not really sure of the specifics, but I was told it should be at 8 degrees. And we didn't actually measure that 8 degrees. We approximated it if we did. So maybe next time we can include those measurement tools just to make sure that the launch is okay. And another thing I noted is during the accident that happened, maybe we should enforce safety more. Although I know safety is not really, especially the helmets are not comfortable, but I think the team previously during the launch, it was the propulsion team, but after your suggestions, I think it will be now the airframe team should handle the launch lug with using hard helmets in case there are any such accidents, they should be safe. Yeah, I think those are the suggestions from my end. Thank you.
Yeah, thank you very much. Responding to your first request, yes, there is a question from Daniel. Thank you for your question. So some of us to join will be still in session. Oh, okay, so if you are still in session, you cannot join because this is a full-time internship. However, you can join as ordinary Nakuja members during your spare time. And maybe the good news, I think we are going to hold 2 internships for this time, because as I heard, in the 3rd year, there is like 2 students, like the one who are going to take internship from January to May, and they are going to do the internship from June to August to September, something like that. So I think we can continue. Even after May, we can continue the internship. So we can take up new students. For example, the Emmanuel Ogueno, Nakuja members in Airframe, he has told me that he's such a student who is going to start the internship from June. So in this case, we can take him from May or June, so that we can continuously continue the internship. So Daniel, if you are a student who is going to start the internship from June or May, you can join at that period. Thank you. Felista, go ahead.
Good evening. On behalf of Active Fin Control, we have a few things we'd like to share. Okay, allow me to share my screen. Can you see my screen?
Yes.
Okay, so this is our flight analysis. So our objectives were to eliminate the roll along the z-axis, maintain stability, and achieve maximum apogee of about 500 meters. So achievements, we managed to successfully eliminate roll, maximum apogee was achieved, and stability was successfully achieved, as you have reported. Yes, some challenges we faced was assembly of the rocket. yeah, this hindered us from attaching the fins as well. Also, I think the issue that has been raised lots of times of the coordination of the teams was also a big issue. Then the recovery of the rocket, as we are expected to recreate the same system. It would have been nice if we would have recovered some things, but we lost things such as our motors, etc., and I think a number of fins. Yes. Then a recommendation we would be a control flight. Like we would like to see how the same rocket would perform if the canard fins were not actuated. Then acknowledgement, we'd like to acknowledge the Nakuja team in general for being with us through this entire time and working together. Then we'd also like to acknowledge you for giving us this opportunity to actualize our final year project. And thank you. I think that's all we have, unless Natalie has something to add.
Thank you, Ferista. Yes, Natalie, go ahead.
No, I have nothing to add. She went through everything I had in mind.
All right, thank you. Yes, control flight, that's a good point. I think, yes, in terms of the research, it's the must, it's necessary. So that should be considered for the other way forward. But yeah, you will, yeah, let me say good job. It's well done. And thank you for your contribution. Michael, please go ahead.
So my suggestions again on the team, as Jeff has suggested that we have a team leader. So what I have experienced in the industry, I think I was at an attachment where we had also weekly meetings where each individual would present a progress, but then we scrapped that for having weekly meetings for individuals instead. And I think so currently what I see is industry standard is they have short meetings daily, like their short meetings daily called stand up, like half an hour, where everyone like says what they did yesterday and what they're working on today. So I think this really keeps everyone like to keep on track, since it's difficult to remember like what each member did 1 week ago. But then if we have really precise tasks, and then we can have a short meeting, like what is called the stand-up meeting, like half an hour meeting where each individual states what they did yesterday, what they're working on tomorrow. And then now for the weekly meeting, we instead have the team presenting instead of individuals. So, and it doesn't necessarily have to be the team leader. So it can be rotated within the team, but then the weekly meeting belongs to the team, where the team like reports the progress towards now the final goal, instead of having a weekly meeting where each individual states what they have worked on within the week. Yes. That's
all right. Very good. And Rodney summed up, and I also agree. Yes, let's have the stand-up meeting. Let's task the stand-up meeting for each team, and in the entire meeting, each team will present. Yes, thank you. Jeff?
Yeah, so I'll just start from what Michael has said. So I think the idea behind our stand-up meeting, it's stand-up, so should be short. Like each person has like 2 or 3 minutes. So it's what you did yesterday, what you plan to do today, and what I wanted to add is any challenge that you are facing as pertains to either what you plan or are going to do, or the previous day. That is the bit I wanted to add, the bit about challenge. I think that the 3 core concepts behind a stand-up: what you have achieved the previous day, what you are planned to do today, and any challenges that you have. Then I have some more good news. So it seems like we were worried that when we take interns in May, we might have insufficient number of applications. But after doing inquiry from, I think January 2023 will probably be the last time that we have in January interns, because those who are in their third year, first semester, going downwards, they've reverted back to the normal system where people go for their internships in between May and September. So unless things change, those who are in their third year, first semester, all those who are in their second years, and all those who are in their first years, their internships will be in May 2023. So what that means is Nakuja can actually be active from January to September, the whole of next year. And then come September, probably some people will take it up as a final year project. So next year can be quite a busy year for Nakuja. And I just wanted to put that out. So I don't think insufficient number of applications is really an issue now, considering that for this first application, we got over 160. So yeah, I wanted to just let you know about that. So it's not only third years, there are second years and first years, which I think would actually be good in terms of getting younger, or those who are those who can be in the project long enough to actually understand it better, considering that we are leaving. Yes. Then I think I just wanted to say a big thank you for the opportunity that we've had for the last 3 years to be part of Nakuja. And it's been a pleasure. We are still here, but I think I should say thank you all the same.
All right. Yeah, thank you for your warm words, Jeff, and your informative information. Yeah, that's good. The Nakuja will be very busy next year, which is very good. Yes. Ian?
Yes, this is actually Christian.
Oh, okay.
Yes, so I only have 2 suggestions. I'll keep it brief. The first suggestion is regarding interdependence of the subsystems. So as the systems really need to work together, we must also look into isolating some certain components. For example, the storage. This is just to reduce the single point of failure. A good example would be the flight that we just had. The telemetry was not able to store the data in the SD card, but the flight control team was able to recover data. So to use a centralized storage system would not be efficient, because if that system fails, we would not be able to recover any data. And my second recommendation would be on updating the README files of the projects that we have on GitHub that we've already currently developed. This is just to increase the transparency of the code, and just to help the newer members to just have an easier time to understand the system, and to be able to use it themselves in their own machines, and to help with the understanding of the whole project in general. So that is that for me.
Yeah, thank you, Christian. The comment on the redundancy, yes. I couldn't, sorry, could you say that again about the second point? So GitHub, which function on the GitHub you are talking about?
The documentation, the README files about the code that you already have. If you're a final year student and you've been working on a project, just to update the documentation so that it's as transparent as possible, so that the newer coming members will have an easier time to understand what is going on, so that we don't have to, the next team will not have to redesign and try to reinvent what has already been done. So this is just to facilitate the development process and the growth in general.
Yes. README files. Yes. Okay, I understand.
Yes.
Thank you. I was seeing June was raising hand. Something to say, June?
Good evening. I think Christian has just reiterated exactly what I wanted to talk about. And I think my concern was in not only the README files, but also having proper documentation and manuals if available. I remember like when the interns joined, the first 2-3 weeks is chaos, trying to understand exactly what was going on, especially being that a majority of the interns will be fresh. There won't be a lot of people that there won't be a lot of them that actually have a clear understanding of what has gone on. Having good documentation, having manuals if available from from the people who are leaving would be of great help. I think that's basically what you're saying, and Christian has said exactly that. Thank you.
All right, thank you very much. I think we exhausted the question and comments, suggestions. Yes, then finally, can I ask Dr. Mushidi to give some comments?
Okay, thank you, Dr. Okay, sorry, I joined you very late. I was on transit. Then my network was also not very good. I hope I'm audible.
Yes.
Okay, good. So I missed a lot, especially on the happenings during the launch. But all the same, I think I appreciated at least what I saw. At least you're able to do the 3 launches. And well, I think I'll read the report so that I get to see exactly what transpired. Now, with regard to the internships, I don't know whether maybe we might also want to think of reducing the groups. How large are the groups normally, like for avionics?
Yes. So can I share it again? Have you been hearing my presentation about the internship?
No, I did not get to. Okay. I know I did not. I was, yes, I had not joined.
Oh, so let me, yes, just clarify. So there are 4 topics and 3 teams.
Yes.
You can see there is no flight control. That doesn't mean flight control is not important, but this time we want to focus on some topics like recovery and this airframe. And okay, so there is advice from Felix. So this is to be determined, but basically the solid propellant and liquid propellant.
Okay.
Yes.
Okay. Yeah. Because I thought maybe sometimes when the group is too large, then maybe the it can work positively, but it can also work in a negative way. But now that I'm seeing we'll have 5 and then 3, I think we should be able to evaluate how effective the groups are. So I think that's in order. It's a good thing that the students noted the issue about leadership, especially amongst them. I think that was something that needed to be more elaborate. But again, the project is supposed to be student-led, so they need to be able to also identify someone to lead and coordinate their activities. Okay, then finally, maybe just a comment with regard to what was happening with the launch and maybe how the rockets are unstable. I think it is expected because after the entire assembly and the components are put together, I am not sure whether anyone ever tries to determine where the center of gravity is. So you might be having too much weight at the top. The weight could be on the side, because I am thinking of all the circuits that are normally put in. I don't know whether they are put in as per the designs that were done in, let's say, what do you call it, like in Inventor or whichever other software you use, where you also then calculate the moments of inertia. Then you, after determining where everything is, and if you want a stable structure or rather a stable rocket, then the components need to be distributed in a particular way. If they use that, then it's okay. But I highly doubt that that is actually the case. And that might explain why it is at the moment the thing goes up, you notice that it already starts turning in a certain direction, because it's basically leaning towards where the weight is. But I think that is just a point of improvement. Overall, I think it was a good effort, because the key thing to note is that the project is entirely student-driven, and I'm really glad to note that the students are able to actually pick out where the issues are and how it is that it can be improved in future. I think that's all I have to say for now. And thank you very much.
Thank you very much, Dr. Mshiri. Yes. I remember the Rodney's question and I didn't respond. So he requested the internship for 4 months. like from January to May, are there any demand of such a long period? Because what I felt is, during the internship this year, my expectation is something like that. So the first batch can continue to the end of the internship. However, most of the students were disappearing, like after 8 months, because the kind of indicated period is 8 months on the whatever the logbook. So once the 8 months passes, that's maybe on the 9th week, one student disappear. The following week, another student, and the following another student. So that's why I faced. That's the thing I have observed. Rodney, do you think are there anybody who can continue for entire period, 4 months? If you are around. Oh, maybe you are not there, or maybe, yeah, I'm going to ask you in person. But anyway, yeah, let me consider such an option. Okay.
Okay, Dr. Oki,
Yeah.
I think
Yes.
maybe what normally happens is the students may not be able to run for the entire period because they also need to do some housekeeping. And that's how maybe someone is transitioning from one year to the other. They need to relocate maybe from the hostels, and they also need to go home because it's also the same time when they have their break. So that might explain how it is that they decide to disappear. But what I know is that there are some companies that insist that if a student is going to go there on attachment, then they do like 3 months. That's 12 weeks. So the minimum is 8. Some will insist on 12. Where I know students stay for 16 weeks, it's where it's actually a paid internship. So someone is actually interested in making an extra coin. That is my observation, but that is now from my point of view. I don't know how it is from the student's point of view, but I think beyond 12 weeks, it might be a challenge to contain many students because, again, of those things of maybe they also need to travel home and such other things. And so 3 months, 3 months may be the maximum time you might expect someone to be there, but it would be good to get a commitment from the onset to know for how long are you staying, because that's the other thing. You can indicate the time that you will be with the project. Is it 8 weeks? Is it 12 weeks? Is it 16 weeks?
I
Yes.
see. Yes. Yeah. Thank you. Yeah, thank you very much. It's much clearer. Yeah. Thank you. Okay, so 2 hours passed. So now I think we can now close this meeting. Anybody have? Oh, Samuel, go ahead.
I'm sorry, I understand time has passed by, but just based on what Dr. Mushiri said, could you kindly go back to the timeline you proposed for the way forward for the rocket, the preparation of the rocket?
This? Or
yeah, next.
This?
The one with the time where we should have everything 1 week before ready.
Okay.
Slide number.
This. Is this the one? Yes.
I just wanted, yeah. Thank you. I just wanted to know, is it feasible to actually have the rocket ready, considering that we may be using crimson powder and the propellant? Can we actually assemble it before time in terms of even, is it safe? Can it, is it safe to do so? And can it stay for 1 day? And when we are also like commuting, if you're commuting on a bus, will it be safe to go with the crimson powder and also the propellant inside the rocket body?
Yes, it's completely possible. I think maybe you, yes, here it is. The casting of motor and crimson powder, something which can decay is it should be done a day before or 2 days before, but other things should be completed way before the launch. So that is my suggestion. So as you mentioned,
Okay, so if I get
yeah.
it right.
So such a pyrotechnics.
So assembly.
Go ahead.
So assembly should be on the day of the launch or one day before the launch. Assembly of the motor and the recovery.
Yes. Maybe yes, that full assembly or the inserting the crimson powder should be done on site. However, actually, what I'm saying is, you need to consider my suggestion, which is the upgrading of the airframe, so that it should easily accommodate all the avionics bay and the parachute and the nose cone and everything, so that basically in a few seconds or in a few minutes we can easily insert the crimson powder and pack it. Okay, so that we don't have to basically consider the time or lead time required for assembling. Okay, so yes, so everything should be done before. I mean, I'm suggesting that we are going to conduct an integrated test by measuring the weight, center of gravity, and center of pressure 1 week before with the crimson powder, of course. But we will just discard the crimson powder, and we will put the new crimson powder a day before or 2 days before. Yeah, so that is feasible.
Thank you.
Yes, thank you. Okay, any final comments?
Yes, so this is regarding the flight data of the recent launch. Everything is posted on Slack for anyone who's interested in seeing it.
Oh, okay, thank you very much. There are 2 files, right?
Yes, for the first and the second rocket.
Okay.
Yes.
That's good. Thank you very much.
To add on to that, I have a suggestion. Can flight control also share an analysis of the data and how they think they control the role if they did? Yeah, that would be good.
Yeah, thank you, Michael. Sami?
We save the data as protocol buffers, so it will take some processing, but we'll have a full flight report.
Very good. Thank you, Sami. Oh, by the way, I will request the KSA to send us the footage. There was one media person who was shooting the videos and photos. So I will send a reminder next week so that we can get it. And I hope you will be able to use it for your final year presentation.
Actually, I had asked him to share the footage on a Google Drive. So I had taken his email address and I had asked him to, if possible, he can upload the footage on a Google Drive to so that it can be shared with us.
Oh, very good.
But
Thank you,
still,
Sami.
from your end, you can remind him.
All right, good. Thank you. Maybe could you send his contact to me later?
Yes, right away.
Oh, good. Thank you very much, Sami. What else? I think that's all for now. Yes, so thank you very much for your participation. And one suggestion was very interesting and important, the weekly meeting or bi-weekly meeting. Let's periodically have the meeting. I think our next agenda will be the internship. So I have received many suggestions for the internship. So let me formalize the internship. And as you suggested, we are going to have an orientation session by the senior students. So let me propose something. so that you can contribute to the next internship as an advisor. I think it will be done in the next 2 weeks or even next week. Yes. All right. Thank you very much. Again, it was a wonderful experience, even for me. So yes, let's continuously work together then to achieve our final goal. Thank you very much and have a nice evening. See you in the next meeting.
Okay, you too. Thank you.
Thank you.
Bye-bye.